All right, in 9.2, we want to talk something called radius of convergence. We use R to denote it. Now, what is R? Okay, R is the definition is the following. That's the definition, namely a power series. Okay, so what is this? So R is something like, so given a power series, in general, let me write a summation A. In our book, they use CK, x minus A to the K from 0 to infinity. Okay, this is a power series with center at A. Okay, center at A. Now, this series there are three possibilities. One is that this series, okay, this series, when you put on this series, converges only for x equal to A. There are only three possibilities. One is that this series converges only for x equal to A. In that case, okay, this is A, and this series converge only at this point. So what this means is that then in this case R is 0. The radius of convergence is 0. If the series converge at only one point. Now there's a possibility that this series converges for x minus A, actually converges absolutely for x minus A less than R, and diverges for x minus A greater than R. So this is A, and this is R. The series converges absolutely for this area, less than, okay, absolutely here, inside, absolutely convergent here, but it is divergent outside, okay, diverges for x minus A greater than R, and this number R is called radius of convergence. This is also called this R is called radius of convergence. The third condition is that this series converges absolutely for all x. If that is the case, the radius of convergence we define to be infinity. Okay, so there are only three possibilities. One, either it is 0, or it is a finite number, or it is infinity. Only three possibilities: this, or this, or this. And this is called, this particular number R is called radius of convergence. Now, how do we determine R? We determine R through, the way to do it is through the ratio test. The way to determine R is from ratio test. Okay, that's the only way to determine it. So, okay, so why don't we look at some problems here? Okay, so 9.2. Alright, 9.2 problem is 9 to 27. So let's look at number 9. Number 9, okay? I'm given a series 2x to the k, and they want us to determine the radius of convergence of the following power series, then test the endpoints to determine the interval of convergence. Okay, so there are two problems here. One is two questions. Okay, I'm going to write question is one is to determine, okay, to find out what the radius of convergence is. What the radius of convergence is. 2, to determine the interval of convergence. Okay, the two things we're doing here. Now, the first thing is easier to do because we can use ratio test to do it. Okay, so how do I use ratio test? Well, AK, that's for number 1. Okay, yeah, AK is 2x to the k, right? How about AK plus 1 is 2x to the k plus 1. So if I look at limit, AK plus 1 over AK, k approaching infinity, okay? This is what I'm looking at, k approaching infinity. 2x to the k, 2x k plus 1. So this is equal, now it cancel, right? So this limit, k approaching infinity. I can cancel, right? Cancel something. K plus 1 is 2x. But 2x has nothing to do with k. So this is 2x. Then I'm going to put the absolute value here, okay? Absolute value. So this is the absolute value. This is the absolute value. Okay. Now, the ratio test says what? If this limit is less than 1, it is convergent, right? So x is less than 1/2. It is convergent. But since we're taking absolute value, so it is absolutely convergent since we are taking absolute value in x less than 1/2. So if I look at this wording, right, and look at my definition, the series, okay, here, and this is number 2. This series converges absolutely for x minus a less than r, this guy. The a is 0, r is 1/2. Okay, r is 1/2, a is 0. So for this problem, it's 1. Therefore, US. The radius of convergence is 1/2. It's 1/2. Okay. All right. So what do we know? So let me just, before we go on, let me just line up all this. Math 114, 003. Today is 14, right? It's 2. Okay. All right, so 1 is okay. 1 is solved. This is 1. Problem answer to problem 1 to determine the radius of convergence. Yes, we have found it is 1/2 here. Okay. Now the second problem is a little bit difficult. To determine the interval of convergence. Okay, so what we know about this series? Say this is 0. I'm going to just write bigger, bigger. I know that it is absolutely convergent here. I know it is divergent here, outside this. But there are 2 points I don't know. It is this one and this one. Those are end points of this interval. I do not know what happened at these 2 end points. And you cannot determine the behavior at the end of these 2 points by the ratio test, because for those 2 points, the ratio test is 1, which is inconclusive. So you have to use a different way, okay? So those 2 points, okay, now, so this is 2, okay? For the end points,
Professor, why is it divergent if it's less than minus half?
because it's here. It is convergent for x between absolute value of x between 1/2. So it is absolutely convergent here. Outside here is divergent. But outside, this is greater. It's divergence for this greater. I have a problem is to equal. I need to determine what happens when this equal to r. Okay, equal to r is the end point, same as the end points. So for the end points, we need to determine whether it is convergent or divergent. Okay, there are 2 end points. One is minus 1/2, one is 1/2, right? So for the end points minus 1/2, the series becomes what? Okay, you have to substitute x by this. There's 2x, okay? K, right? So that's the problem. You see? 2x. Now the x is negative 1/2. So that's the, this is this guy. When at the end point, negative 1/2. And okay, so 2 and 2 cancel. So it's summation negative 1 to the k. This series is divergent. Okay, it's divergent. And now for the another end point, 1/2. Okay, the series becomes 2 times 1/2 to the k, which is 1, right? 1 to the k is always 1. Okay, that's also divergent. So therefore, the interval of convergence is from minus 1/2 to 1/2. It does not include endpoints because at the endpoint there it's all divergent. So that's why if you have book, it says this. Let me show you the book. Okay, before I have the book, it says this. Determine the radius of convergence of the following power series. Then test the endpoints to determine the interval of convergence. And we have to test the endpoints. So that's what I did. Okay. All right, let's look at 3, right? Let's look at a little bit different Well, let's look at number 9.